Welcome. This is a ECE 4960 project video. For this project, we were assigned the remote-controlled bicycle. Our team name is BK2, and the members are Brian, David, Suzanne, Mitchell, and David. The purpose of this project is to design and create a fully automated Bluetooth-controlled model bicycle. The bicycle should be able to balance while in motion, steer left and right, handle various terrains, and use a kickstand. The first step to any project is brainstorm and development. We had already received our model bicycle, and we knew that we would need a positional motor for the steering, a continuous motor for driving, and a positional motor for the kickstand to be raised and lowered. These would be controlled by a TiVo, which we thought we would mount in a rack behind the seat. There were four main parts to this project: the motors for driving, steering, and operating the kickstand, the IMU, the inertial measurement instrument, which would sense the changes in the lean angle, the Bluetooth interface in order to control the bicycle, and the TiVo in order to relay the commands to all the motors. This is how our bike ended up being designed. First, you will see that our drive motor is moved from above the chain to directly on the sprocket where the pedal would have been. Second, the steering motor is now above the seat instead of on the frame. This allowed for better control of the handlebars. And the third motor, the kickstand motor, is actually mounted where it was in the drawing. We ended up designing a rack that would mount behind the seat to the bike in order to hold everything that was not mounted directly to the frame. The first thing that you will notice is the IMU. This was mounted on the bottom of the rack and was parallel to the ground. This would sense all the change in lean angle. The second arrow is pointing to the Bluetooth module. This was connected to the TiVo and would receive inputs that were sent from the phone in order to tell the bike whether to speed up, stop, or turn left or right. The third arrow is pointing to the TiVo. This was mounted on the side of the rack and controlled everything about the bike. The very last thing that you will notice is a battery pack that was mounted out to the outside of the rack. This was to counterbalance some of the weight from the drive motor. This picture shows all the calculations that were needed in order to figure out what the steering angle would need to be to correct the lean angle to keep the bike upright. We used these measurements to calculate a transfer function based on the inverted pendulum concept that gave us a ratio of the lean angle to the bike and the steering of the bike. This is the formula. We calculated our two poles, and then we needed to find another pole and a zero to the left. We came up with a 0 of 15 and a pole of 40, and we tried various gains but settled on 40. This simulating diagram shows our steering and lean angle feedback system in action. The top graph shows how closely the actual lean angle follows the desired lean angle when simulating our feedback system. The graph on the bottom shows the steering angle quickly oscillating to keep the actual lean angle as close to the desired lean angle as possible. This is a state flow diagram. It receives a Bluetooth signal, and based on that signal decides whether it will go to the driver gate block or the steering block, or do nothing. This is another model that shows, based on the input, what will be output either from the driver's gate or the steering gate. This is a Bluetooth controller that we used off of a cell phone. The left and right controls meant to steer either left or right. The X button meant to go slow, circle was fast, and square was stop. This is an example of the steering. Unfortunately, we had some issues on presentation day, but you can see that the steering clearly went from left to right, and you can see the maxes on each side as well. This is an up-close view of the steering, how the actual motor connected to the handlebars and would turn the wheel back and forth. Here you can see the bike driving through the classroom when we were presenting.